Hello, everyone. You are welcome once again to today's class. And in today's class, we are going to, or we are still looking at sets. Okay, we are going to continue from where we left off. Okay, in lesson 4 of sets. So meaning today's lesson will be lesson 5. Okay, and in lesson 5, basically we are going to look at all that we've learned. Okay, in lessons 1 up to what? Up to 4. In dealing with what selected, okay, or likely exam spot questions. And these questions are picked from what the past questions basically. Only that some of them, okay, I have changed it or altered it a little. Okay, a little. So if you are able to do these questions, then it means indeed you have arrived. And as and when, like I've told you, in math, you have a whole lot of methods usually. I mean, you don't have one method of solving a particular question, usually. Okay, however, you always have one ideal method. One ideal method. And it's that ideal method, like I've always been saying, okay, I will plead you all try to what adjust in presenting your solution conform to that what method. Okay, so without much ado, let's look at what the first, okay, set of questions under the solved past questions or likely exam questions. Okay, so we are supposed to simplify the following. Simplify the following. We are going to start with the A. And A, we know its nature. Okay, we are not worried at all. All the questions there, we know their nature and we will know how to deal with it. Only that as we move along, I will be giving you hints, okay, or I will be advising you, I will be instructing you that this is the best option, okay, to go about it as always. So quickly, when you read the question, okay, if there is any salient part, you underline. Otherwise, okay, you come and write the major question number, which is question 1, okay, and the minor question number, which is A. And please, okay, you don't write on top of even solution, you don't write simplify the following. If you want to write simplify the following, then you have to write all the following before you come and write your solution. So after reading the question, okay, what you need to write or what you are supposed to write will be solution. Okay, nothing, okay, from this part of the question should be above the solution unless you want to write everything. So it's either you write everything or you ignore. That's my point. You ignore everything before you come and write solution. Okay, so question 1A, what are we giving? Okay, I can choose not to write the giving, but this I must extract. And take note, this in itself is not a question. The question comes with this. It is this, okay, indirectly, the preamble here that makes it a question because you are supposed to simplify. Okay, so in this case, we have root of 50, okay, and minus, okay, 5 root of 32, okay, then minus 3 root of what? Root of 2 into, okay, 2 root of 2, okay, then minus 5. Okay, so this is what we've been given. Okay, any ideas based on what I've told you? What do you think will be the first step, okay, to be your first one, your very first step? What do you think that will be? Okay, based on the advice that you've been given. Okay, in any case, there's an expression we start equal to. Okay, if you start with multiplication, you are doomed, and you cannot also ignore the equal to. So take note. Any ideas? Okay, as to what you are supposed to, assuming, okay, Prof. Paulette Paris.
Please breaking down the numbers into a perfect number and rational number.
Okay, so
Irrational.
in effect, what are you doing? I want you to speak the language. In effect, if you are breaking down, what are you doing? Okay, so let me see if somebody's on. Okay, Prof. Mamia.
Simplifying the sets if it's you're able to simplify
Okay, so
further.
I want some keywords. That's it. That's okay. Only that I want us to be using the keywords for us to know that we are matured. Okay, Prof. Leslie.
Please simplifying it to its basic form.
Okay, so expressing it in its basic form. Okay, that's all that. So thank you very much. Okay, did you are my professor? So now this is it. So yeah, any set that you can take it to its basic form. okay, you do so before you think about expanding. I've told you that's the very first, okay, point of call. So this said, it's not in its basic form. So we know how to, thankfully, okay, unfortunately, we know how to take it to its basic form. So we write this one as, okay, root of the highest perfect square will be 25. Okay, then times 2. Okay, then minus, okay, 5. Root of the highest perfect square will be 16 times 2. Okay, then you keep your, if you like, whilst you are simplifying this, you can equally come and expand this. So it means in that really you are working on all the terms. Like I said yesterday, okay, if any term must be worked on, you work on. Only that if you deal with it systematically, that's okay. Reduce before you expand. But you can do the two together if possible. So that's what I am going to do. Okay, to show I'm more matured. So in this case, what do? I will now come and expand those. So that will give me the 3 root of our rate. I've written the negative already. So 3 root of 2 times 2 root of 2, and that will give us 6 into 2. You agree? Because to be 3 times 2, which is 6. Okay, then root of 2 times root of 2 to give us root of 2 squared, and that will give us 2. All correct. Or somebody can write 6 root of 4 is allowed. Only that, like I've told you, that will not be the matured way. Then you come to minus 3 root of 2 times minus 5. That will give us positive. Okay, 3 times 5 will give us 15. The root of 2. All correct? It's my point.
Please come again.
I should
Please
come again from where?
From how you got the 6 bracket
Okay,
2.
you are multiplied. So assuming I've given you 3 root of 2. Okay, times 2 root of 2 or 3 root of 2 into 2 root of 2. What will you do? How would you expand this? Because we've gone beyond this.
The 3 multiplies
The
2.
3 will multiply.
The 2. And the 2 is the same as
so the 3 will multiply the 2 and give you
6.
6.
Then since the root of 2 and root of 2 is the same, put bracket 2.
It will give you
Bracket 2.
into bracket 2.
Okay, thank you.
You see, you are there. I don't like that. Stop that. All right. Okay, so this is it. Maybe she wanted to announce her presence. Okay, so we know you are here. Okay. Okay, because I know this is below you. All right, so
Yes.
this will be equal to, okay, so we know, I've told you, as for the step where you write root of 25 times root of 2, it's not necessary. So once you split it this way, this is the perfect square. So root of 25, we know will give us 5, then root of 2. Okay, then minus, this will give you 5. If you simplify what you have here, we know it will give us 4 root of 2, all correct. Then minus, this gives us 12, then plus 15 root of 2. All clear?
Yes, please.
Great. Okay, so now this is going to give us, okay, if I like, I can combine but let me remove the bracket before I finally come and combine any like terms. So 5 root of 2 will be kept intact. This will be the bracket that I'm supposed to remove, and that will give me 20, okay, root of 2. Okay, then minus what? 12, then plus 15 root of 2. Okay, so at this point, we are in a comfortable lead. Okay, we ask ourselves, after expansion, meaning after removing all possible brackets, okay, do we have like terms to combine? Okay, in that case, let's see. Yes, we do. The third here, I have 3 set terms. They are all like terms because they have the same radicand. So it means we can combine. So I want to see whether if I combine my set terms, I will get what do you call a positive result. If it's a positive result, I'll start with it. If it's negative, then I'll hold on and go and look at even the next one. Okay, the answer is negative. So it means I can even start with that one. Because but here, if you look at it, you know that this will give you, okay, 5 root of 2 minus 20 root of 2 give us minus 15 root of 2. Then plus 15 root of 2 give us 0. Do you agree?
Yes, please.
So in effect, we'll be left with only minus 12. So at that point, I know that the minus 12 is going to be my last statement. okay, which indirectly will be my last answer, I can come and have my conclusion drawn. Therefore, okay, root of 50, okay, minus 5 root of what? 32, okay, minus 3 root of 2 into, okay, 2 root of 2 minus 5 will be equal to minus 12. And usually, okay, when your expression that you are supposed to conclude with is lengthy, okay, we can choose not to give marks to your conclusion, meaning if you come and write equal to minus 12 in certain situations, but however, okay, the advice is always draw your conclusion because you don't leave yourself, okay, to the mercy of the person who is marking or the person who is what preparing the scheme. So whether what I have there is lengthy or not, I'll draw my conclusion. In case marks are given to the conclusion, I am still okay there. If it is not, I have nothing to lose anyway. Okay, just a little time that I have lost, but that's okay. I have protected my marks. Okay, Prof. Leonard.
So please, I wanted to ask that after you got your conclusion, why is it that you didn't add the root 2 to it?
The root 2. Okay, the root 2, all the root 2, all the set terms go. Because you realize that this plus this will give you 20. 20 root 2. So 20 root 2 minus 20 root 2, just like x minus x, that will give you 0. So your set terms will go.
Okay.
You'll be left with only this one. You get it?
Yes, please.
Okay, all right. Okay, so Cedric, we are here. We've heard you. Okay, hi. Okay, Prof. Paulette Paris.
So please, I wanted to ask that you see that the 12 could be broken down into four and 2. It could
Which
be
one?
broken
Which
down.
one? This one.
The 12. Yes, please.
No, this one is not a radical, so you forget about breaking it down.
Okay, so you don't have to leave your answer in the set form.
No, this one is not a set. So once it's not a set, you cannot leave it in terms of set. This is a rational number. The sets were this, and the set cancelled in the long run. So you want to
Okay.
tell me that if you have, what do you call it? Let me, 32 as your answer, and you are dealing with set. Okay, you take 32 to set. 32 can never be set because it's a rational number.
So please, I've seen my mistake. Thank you.
Okay, all right, you're welcome. Okay, so now this is it. We are going to move on to B. Okay, if you don't have any questions, further questions, then let's move on to, okay, that of the B. Okay, you leave a line, at least a line, maximum 2. I said line 1 will be okay. So you move on to the next one. The next one is what? Root of 7, okay, into what? 3 root of 7, okay, then minus 6 root of what? Root of 7. Okay, so let me see the approach that, okay, some of you will go. Okay, you can see that inside the bracket here, you have a set, okay, in the denominator. So let's see, how best would you deal with this? If maybe this question was given to you without my input, how would you have dealt with it? My professors, are you there?
Yes, please.
Okay, so
Yes,
please,
please.
how would you deal with this one? Okay, Prof. Jojo.
Hello, sir.
I can hear you. In fact, we can hear you.
Please, I would have made the one in the bracket into a single fraction, then cancel the denominator with the 7 outside the bracket.
Okay, that's okay. Very good. One method. Okay, the beauty of maths. Let's see whether we have another method. So that's what Prof. Jojo will do. Okay, what would you do? That's the question. What will be your approach? Okay, Prof. Laurentia.
So please, like I'll find the LCM for the one in the bracket.
That's
After
what he said. Okay, after that, you continue. Sorry, maybe after that, your approach will be different. After
so
that.
that's the same thing.
Okay, so it's the same thing. So it means so far. Okay, that's what you are. Okay, so somebody said, Lola, okay, said, okay, say I will expand. She will expand. Okay, another approach. Okay, Prof. Farid.
That piece I would have also expanded.
Okay, so please, the best way is to expand. I know someone can also say that I'll rationalize because you see a set. Anytime you have a question, okay, and you see a set in the denominator in bracket somewhere, remove the brackets. It's possible that maybe after removing the brackets, you wouldn't have any rationalization to do. So let's go that route and see. So this will be equal to, okay, in this case, if I expand, okay, because you know the first step is to check if you have any set that can be reduced to its basic form. Okay, so we realize that the set here are all the sets are in their basic form. So that one, okay, patched. So we are moving on to the next, okay, step, which will be either we expand or we make this a single fraction or we rationalize this. But we said expansion will be best because if you expand, you are going to get 3, okay, times root of 7 squared, which will give us 3 into 7. Do you agree? Then minus, if you multiply this and this, okay, you know the root 7 in the denominator will cancel the root 7 in the numerator. So in effect, you get what? Minus 6. Should I come again?
Yes, please.
Okay, so if that's the case, then that's what I'm going to do. I'm going to write a step which will not be that critical, meaning you can ignore in your presentation. Okay, so let me deal with it this way. So let me take opportunity to clear this as well. Okay, all right, so don't worry, you'll get it if you are not there yet. Okay, so this is what we have. So we are expanding. So indirectly, this is it. You are going to get root of 7, okay, times, okay, 3 roots of 7. You know, it will give you 1 times 3. Okay, let me equally clear this and deal with it the way maybe you can appreciate, okay, better. So that will give me 1 times 3, which will give me 3. Then root of 7 times root of 7. So that will give me into root of 7 squared. Okay, then minus, this is going to give me, okay, root of 7 times 6, and that will give me 6 root of 7 all over 7. Can you root of 7? Sorry. Do you agree?
Yes, please.
Okay, you know, okay, I did this mentally. So this will cancel this because now they are factors. So this can cancel that. Okay, so in effect, we are going to get, so you can see that I move from this step to the step that I'm going to right here, which will be 3 root of 7 squared, we know is 7, then minus, this will cancel and give us 6. Okay, so this gives us what? 21 minus 6, am I right?
Yes, please.
Okay, so now you know, okay, your whatever you write here will be obviously your last step, which is your final answer. So you can have your conclusion drawn with that. Okay, so root of 7 into what? 3 root of 7. Okay, minus 6 over root of 7. Okay, and that will be equal to 21 minus 6 will give us,
15.
okay, so 15. That's it, as simple as that. Is my point well made, my professors?
Yes, please.
Okay, so we are going to do one more. So here we had a monomial multiplying a binomial. So let's go and look at this. Then after that, we take one of the binomials multiplying. Okay, so we'll look at that one where one contains a fraction. So quickly, let's look at that of what? The C. Okay, C, what are we giving? 3 root of 2. Okay, in brackets, 3 over root of 2. Then plus root of 2. So again, now we know anytime we have questions of this sort, we won't take the LCM. Okay, we will expand. Okay, and if you expand, it's likely we'll land at whatever we are looking for. So this will be equal to, it will be this times this, but because I know I have root of 2 in the, or you let me write it before so that you can really relate. So it will be my numerator here multiplying the numerator. So that will give me 9 root of 2 all over root of 2. Do you agree? Okay, then plus, we are going to get 3 into root of 2 squared, which are, you know, okay, you can write 2 there straight away. So if we are smart, which we are, we could have moved to this particular step that I'm going to write. But if you want to play it safe, okay, if you want to play it safe, definitely, you can write the step. Okay, so now what do we have? This root 2 will cancel the root 2 there. So that will give you 9. Okay, then plus this will give you 3 into what? Into 2. Because 2 squared, the square will get rid of what you have here. So that will give us what? 9. Okay, plus for 6. Okay, and that is also giving us what? 15. So therefore, okay, 3 root of 2 into 3 over root of 2 plus root of 2, okay, is equal to what? 15. Point well made.
Please come again.
Yes, please.
Okay, I should come again from where, my professors?
Please, the first step.
Okay, the
Just
first step. Okay, just like you having A, okay, times you are multiplying B over C. Okay, the numerator, this is a numerator, the denominator is 1. So it will be the numerator here multiplying this numerator and the denominator multiplying the denominator. But because the denominator here is 1, if you multiply, the entire denominator will only be this because this times 1. So you are going to get 3 roots of 2 times 3, and that will give you 9 roots of 2. Abi, is that
yes,
not
please.
it? Okay, all over, you can see that you have the denominator of root of 2 all over root 2. So you bring your denominator, and this one, when it multiplies this, you get 3, okay, times 1, which is 3. Then root of 2 times root of 2 to give us root of 2 squared. Or someone can write root of 4, no issues. Only that I've told you, okay, what for the impression that you will send. Okay, but at some point, maybe you can choose not to worry about impression. Okay, protect your marks first. So this is it. I guess you are fine now.
Yes, please. Thank
Okay,
you.
you are welcome, my professor. Okay, so now let's go and look at what. Let's pick F. Okay, with this you should be able to do the D and what and the E. Okay, easily. So let's go and pick what the F. So F, what are we giving? Okay, we are giving 2 root of 5. Okay, minus 6 in one bracket. And in another bracket, we have 3, okay, plus 2 root of what? Root of 5. Okay, so again, with this one, okay, we will try and expand and see. If after expansion you still have a third, okay, in the denominator, then it means it will call for rationalization. So in this case, we know we always expand. After realizing that none of the cells, okay, we can reduce. Okay, so all the sets are in their basic form. We can go straight away and expand. Okay, so this will give us 2, you take the first term here, multiply. You've done, okay, how to expand binomials. But I've told you, anytime you're expanding binomials, don't be quick, okay, to do your normal expansion. Check whether they are special. Same first term, same second terms, okay, same signs or different signs. But here, the terms, first terms are not the same. So obviously, they cannot be special. So we have to use our usual expansion. So this times this will give us for 6
Right, very, very
5.
bad.
It's my point well made.
Yes, please.
Okay, great. Okay, then what do we do? At this point, we are going to get, okay, so we are going to get this one also times this. Okay, but now we are matured. We know that if you multiply, there will be a third in the numerator, which is root 5, and a third in the denominator, which is root 5. So that will cancel. But I'm only going to write it. Okay, but you can, okay, write the matured one. So that will give me plus, this one times this will give me 4 root of 5 over root of 5. But just as I said, this, okay, you could have written 4 there straight away. Then now you come and multiply this and all the terms. So minus 6 times 3 will give us what? 18. Then minus 6 times this will give you minus what? 12 over root of 5. All correct. It's my point well made, my professors.
Yes, please.
Yes,
Okay,
sir.
so at this point, okay, this term I can't do anything to it, so I maintain. Okay, this term I can simplify because root of 5 will cancel the root of 5 in the numerator. So it will give me only 4. Okay, this one I can't do anything, I maintain it. This one, unfortunately, I have a third, okay, a fraction containing a third in the denominator. So it calls for rationalization. So at that point, I will write it straight away. I will rationalize, okay, at that point. So I write it again before I rationalize. Point well made.
Yes, please.
Okay, very
Yes,
good.
sir.
Okay, so now this will give us what? 6 root of 5. You know, don't come and write 4, then minus 18. You know they are like them, so combine them. So that will give you minus 14. Is that clear? Okay, then this will give you minus 12 root of 5 over what? Over 5. Okay, so at this point, you are in a comfortable lead. You know what we did whenever we have this situation. Once the denominator is fractional, just go and take your LCM, because I've told you, you don't leave an expression containing a fraction and more than a term, okay, in more than a term form. Always write it as a single fraction. Remember what I told you yesterday. So here, our next step, but for that, we could have concluded here. So our next step will be the single fraction form of what we have there. So our LCM here, this is over 1. This is over 1. So the LCM will be 5. Okay, 1 goes into 5, 5 times 5. So that will give us 5 times 6, which is what? 30, so root of 5. Then minus 1 goes here, 5. 5 times 14 will give us 5 times 14.
70.
Okay, so that will give us 70. Okay, then minus 5 will go here 1. Then times the numerator here, which will give you 12 root of what? 5. So at this point, you know your next step where you have these two like terms to combine. Okay, you can, immediately you combine that. You are sometimes you have to be careful. Maybe it's possible after your combination, you can factor out something to to reduce. So move. Write it as a single fraction first in a simplified form. I mean, in the raw initial form before you come to see whether, or you come and check whether you can further reduce. So in this case, I'm going to get 30 minus 12, and 30 minus, because these two sets are like that, they have the same radical. So 30 minus 12 will give us
18.
18. Okay, root of 5. Then minus what? Your 70 all over. I would have known that if immediately I got the 18 here, I would know that, okay, 5 is not a factor of 18, and it's also, though it's a factor of what? 70. But once it's not a factor of one of the terms in the numerators, it means I cannot reduce. Okay, unless maybe I'm able to get a number which is a factor of all the 3 numbers that sets there, or that radicals, if I'm supposed to. I could have drawn my conclusion here. However, my conclusion is not drawn. So I'll come and draw my conclusion. Therefore, okay, whatever that I have there will be equal to my result. So you will know that conclusion must be drawn. Is that clear? So I don't want to write that just to save time. Is that okay?
Yes, please.
Okay, very good. So with that, you should know. So it's not always that when you expand, okay, your set will go. My point is, if you expand and your set vanishes, you thank God. I mean, your denominator set or whatever set that you have there vanishes. Okay, you thank God. Okay, however, if you expand and your denominator set, okay, does not, then it means you still have to rationalize. So usually it's expansion before rationalization. Expansion before rationalization. That's not to say that with this one, we could have rationalized this one before expanding. We'll end up getting the same result. Only that it's ideal to expand before rationalizing. Okay, so now, okay, we are going to move on to our second set of questions. Okay. All right, but before that, are we all fine? Is everyone cool? Is everyone cool?
Yes, please.
Okay, so we are asked to simplify the following without using tables or calculator. So I've told you, immediately you see this, you can hide your calculator. Or when you are smart at a point, you can use your calculator, nobody will know. Just I told you the other time, yesterday in lesson 4. Okay, so let's go and look at how best we can solve the following questions. Okay, once again, my approach is not the only approach, take notes, but usually it would be the ideal approach. So after reading the questions, so salient parts without using So that's a word of caution or a statement of caution. Okay, take note of that. Okay, so anytime you are using your calculator, you use that with care. Okay, so with caution. So in this case, I write my major number question 2, my minor question number, okay, A. So what am I giving? Root of 12, okay, then minus root of 75, okay, then plus 2 root of what? Root of 3, all over. What do we have? Root of 3. So now this will be equal to, let's go. You can see first approach, any set that is not in the basic form, take it to the basic form. So obviously we can see about 2 sets which are not in the basic form. So couldn't you have subtracted 6 root 5 and the 12, okay, root 5 over, okay, let me see, which one were you talking about? I think there is a question here that this one and this one. Please, you can. Okay, usually, anytime you are subtracting and you have a fraction, okay, we usually don't do it mentally. Just like if we are giving 1 minus 1 over 2. Okay, the answer will give you, if it's the obvious fraction, 1 over 2. But usually we won't, okay, write it that way. We want you to take the LCM. You get it? Once you realize that they are like terms and one contains a fraction or both contains fraction, take the LCM so that you avoid working with what you have there. So the single fraction will be the best way. I guess I have answered your question. Okay, very well. So now let's move on. Okay, so at this point, root of 12, okay, not in its basic form. So what I will do is I usually want to write the one that involves little or nowhere. So my denominator, I'll write it first, root of 3. Okay, my numerator here, I will come and work on this. So that will give me root of, okay, 4 times 3. Okay, then minus, okay, root of, is it 25 times 3?
Yes.
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 Okay, then plus 2 root of 3. Is that it?
No, please.
Okay, so
No,
what
please.
is wrong?
The square root, it didn't
Okay,
cover.
It's not
so
covering the whole.
so if you are able to correct me, you have no business not to correct yourself. So in the upcoming test, okay, if you do this and I mark you down, okay, don't label me as wicked. Please take notes. Okay, the meaning is not the same. This in actual fact will give you 2 times 3, which is 6. Not what 2 root of 3. So take note. I've told you anytime you split this one into the highest perfect square and non-perfect square, make sure your square root covers everything. So I'm drawing your attention to that once again, okay, for obvious reasons, because some of you are still doing that mistake. So now this will be equal to, we know this gives us 2 root of what? Root of 3. Then minus this will give us what? Okay, 5 root of 3. Then plus what? 2 root of what? Root of 3. All over, okay, root of 3. Don't be in a hurry to go and rationalize because you have a set in the denominator. Remember the advice. If any set, okay, it's not in its basic form, reduce first. Sometimes when you do that, okay, you realize later on that rationalization wouldn't be necessary. So let's see. At this point, after reducing to the basic form, I have seen that the numerators are like them, so I can combine. So if I combine, what do I get? 2 minus 5, okay, which will give me minus 3, then plus 2. So what do I get? I'll get minus root of 3. Is that clear? All over root of 3. Do you agree?
Yes,
Yes.
please.
Okay.
Yes, please.
Please, who wants me to go over? And from where? Hey, today the unexpected has happened. All right, okay, so finally, okay, we thank God. So at this point, this is what we have. This can cancel this. So in effect, you'll be left with 1. So instead of writing 1, then you come and conclude. Okay, I will draw my conclusion at that point. So root of 12, okay, minus root of 75, okay, plus 2 root of 3, all over, okay, root of 3, okay, will be equal to what? minus 1. And you can see that after simplifying, I mean reducing all the sets to their basic form, okay, and adding or combining, or because you have subtraction there, okay, you realize that rationalization, okay, was not necessary because the denominator, which would have prompted, okay, the rationalization now can cancel directly. So you are good to go. All correct.
Yes, please.
Okay. All right. So on that note, okay, let's see if you can do the B. Okay, let me look at the time. Okay, so we'll do the B, then I'll advise you as to what to do with the C. Okay, I mean, we'll do the C, then I'll advise you to do this one will be done as a class work probably. Okay, or a homework, looking at the time, so that we'll have at least maybe 1 hour for, okay, the binary operation. So quickly, let's go and look at what this particular one. Okay, I think I can explain this. Just reduce all the cells, or I should do it. Or
Please do it.
we should
Yes,
do it.
please.
Hey, you, hey. Because my head is big, every load you want me to carry, I won't mind you. All right, so this is what we have. E. Okay, what are we giving? Root of 3, okay, minus root of 75, okay, plus root of 12, okay, plus root of 108. And make sure, okay, all over, okay, root of 6, okay, minus root of 96. So I'll help you maybe up to a particular point. Okay, that I know you can continue, or you can all continue. So 150. Okay, so some of the cells are not in their basic form. So you know, obviously you go and work. This set is in its basic form for the numerator. This set is in its basic form for the denominator. However, all the other sets are not. So I will keep my root of 3, then minus root of 75. We just did that. So that will give us for 25 times 3. And make sure your square root covers everything. Okay, minus, sorry, plus root of 12 will give us what? 4 times 3. Okay, then plus root of 108 will give us what? I'm waiting, whilst waiting.
Times 3.
It will give you 36.
36 times 3.
Okay, times 3. Very good. Okay, make sure it covers. Okay, then your denominator root of 6. Okay, minus root of 96 here will give us what times what? I'm waiting.
16 times 6.
Okay, 16 times
6.
6. Okay, very good. Okay, then 150.
25 times 6.
25, okay, times 6. Okay, so obviously. So please, this is the advice, okay, the hint. Okay, as you are reducing, okay, because you see 3 here, okay, it means one of the factors of the numbers that you are supposed to consider here likely is supposed to be 3. So always check this one divided by 3. Check whether it will give you a perfect square. The number, if the number is anything, that's the number that you are supposed to multiply by 3. Same, okay, here. And because this is root 6, okay, if you can easily combine this, then there should be root 6 here. So meaning 6 is supposed to be a factor of this. And therefore, you divide to get the other perfect square factor, usually. So check for you to know how you can easily get the other, okay, factors or the highest perfect square. So I guess my point is well made, my professors. Okay, so at this point, we are going to get root of 3. This now reduces to 5 root of 3. Okay, this reduces to 2 root of 3. Okay, then this will give us for 6 root of 3. Okay, my denominator, what do I get? This is still intact, root of 6. Okay, this will give me minus 4 root of 6. Okay, then this will give me plus 5 root of 6. So if I move on to my next step, I'm going to combine my numerator and my denominator. Okay, so what do I have? The terms here, all are like terms. So I combine the coefficients and I do it mentally. Okay, so 1 minus 5 will give me minus 4. Okay, then plus 2 will give me minus 2. Then plus 6 will give me what? Positive 4. So I will get 4 root of 3. Is my point well made?
Yes, please.
Oh, so root of 3 and I wrote root of 6. Forgive me. This one wasn't intentional. Okay. So at this point, we are more than good to go. Then the denominator gives us what? Okay, 1, we combine, they are like said because they have the same radical, they are all in the reduced form. So 1 minus 4 will give us minus 3. Then plus 5 will give us positive 2. So I'll get 2 roots of 6. Is that clear? So at this point, you know, okay, I'm going to write this step and tell you what to do from here. So I know that non-radicals can reduce. So this will give me 2. Okay, root 3, okay, over what? Root of 6. So at this point, you can't reduce, okay, this one. So what do? You go and rationalize. You write it again and multiply both the numerator and the denominator by root of 6. You get it, and you continue from there. It's my point well made, my professors. Okay, Prof.
Yes,
Laurentia.
sir.
Please, can't you okay, sir, it's fine.
Okay. Okay, so I think she has what do you call it? Can't herself. All right. Okay, so let's look at. Okay, I think where I'll go for the C. Okay, then as a guide, you can use it to do the D and the E. Okay, so C, what are we giving? Okay, so this question is quite different from what we've done so far. So 1 plus root of 2. Okay, then you have 6 over, okay, 1 minus root of 2. Okay, so this is it. Okay, so you know, anytime you have fractions, okay, even one fraction and the other non-fractions, you know, we said before we can easily simplify, we have to write it as a single fraction. Okay, so that's the point. So we will stick to this same advice. I'm supposed to simplify this. I have a fraction here, a fraction here. The denominator of each fraction not pretty because it contains a set. Okay, the relative math student will have another way of dealing with it. When you go and look at the second case, okay, which will be done, okay, God willing, tomorrow, okay, of what said, where the denominator contains a binomial set. But for format, it's really monomial set in the denominator. So here, this is what you do. So the fact that you've seen a binomial set in the denominator doesn't mean as a format student, you can't deal with it. Okay, so in this case, take the LCM. And what will be the LCM? The LCM will be this one times this. Is that clear? So it will be 1 plus root of 2 into 1 minus root of 2. Do you agree?
Yes, please.
Okay, very good. So you know algebra, JHS algebra. So you now come and ask yourself, this will go into this how many times? And the whole of this divided by this will cancel this. So you'll be left with 1 minus root of 2, then times 4. And because it's a binomial, you have to write the 4 into that binomial. So please listen attentively. Minus root of 2. Then you keep your plus there. Then you come and ask yourself that same question. You repeat the same process. Would the number of times this will go into your LCM? And that will be 1 plus root of 2 times, then times 6. So you write 6 into, because one of the factors, what you are multiplying, one is a binomial, put the binomial in bracket. All correct.
Please come again.
Okay, so just like if you have 1 over x, okay, plus 1, or let me use 2 over x plus 3 over y. Your LCM will be s times y, which is xy. The number of times this goes, your numerator will be the number of times this goes, which will be y times 2 will give you 2y. But here, because 2 was a monomial, y was a monomial, you could easily multiply and write the value. Okay, then this one, same. You go here, x times 3. So 3, okay, x. Monomial, so you can get. However, if one of them is binomial, then you have to write it this way. The monomial, then you put the binomial in brackets. It's my point well made now. Though I didn't use the exact question.
Yes, please.
You are fine.
Yes.
Okay, great. So at this point, please, we are going to remove all brackets. So let's deal with the denominator. We are going to expand. So what will you do, my professors? Tell me what you will do. You put up your hand and you tell me what you are supposed to do. Other than that, I will call you randomly. So let's deal with the numerator first. So numerator, let's do it together. So 4 times 1, that will give us 4. Okay, minus 2, 4 times root of 2, so that will give us 4 root of 2. Then you come here, 6 times 1, that will give us 6. Okay, then plus 6 times this will give us 6 root of 2. Okay, so now let's come to the denominator. We are multiplying a binomial, two binomials, but here we're multiplying a monomial and a binomial. So we've done that one. That should be the easy one. Okay, now let's come to the denominator. In actual fact, the denominator expansion is the easiest. Okay, so here, what will you do if you are confronted with Prof. Leonard?
So please, I'll multiply 1 by 1 minus root of 2, then root of 2 by 1 minus root of 2.
Okay, all right, that's okay. There's nothing wrong with that. Prof. Paulette, okay, Paulette Paris.
Please, difference of 2 squares.
Difference of 2 squares. You know, I've given you all the hints. I've given you. So you see, instead of working harder, okay, work smarter. Okay, and it will save you time. Working smarter means give us the ideal solution. So remember, I just even today, now, I told you that anytime you are multiplying, check whether they are special binomials. Remember in one of the questions I said that. So same first term, same second term, difference in sign. So we know that if you expand, you get difference of 2 squares. So by the time you come and multiply this and this, we are done. Okay, so we will be done. So this will give us 1 squared. Okay, then minus root of 2 squared. Okay, if you don't remember this, there is a lesson on, okay, this nature of questions. So go back, okay, and watch the video. Okay, so in this case, your numerator, this and this are like terms. I can combine, that will give me 10. Okay, this and this are also like terms. I can combine, that will give me 2 root of 2. Do you agree? Okay, all over my denominator, this will give me 1. And this will give me minus 2. Is that clear? Any
Please
issue?
come again.
Okay, from where?
The step that we just did.
Okay, so the numerator, you know, after expansion, always check whether you have like terms. Usually there will be, not always. Okay, so here after expansion, I realized that 4 and 6 are non-sets. Okay, so I can add them. So 4 plus 6 will give me 10. Then this is a set, this also a set. So they have the same radical, so they are like sets as well. So it will be minus 4 plus 6, which will give me positive 2, the root of 2. You should know how to combine these 2 sets. Okay, if you don't know at this point, then it means you have a lot of revision before to do before the test. Okay, then over this one, difference of 2 squares, we've done that. Same first term, same second term school, and different sign will mean if I expand this, it will give me automatically difference of 2 squares. So it will give me my first term squared minus my second term squared. So this will give you 1 squared, which is 1, the root of 2 squared, which is 2. So at this point, we are going to get this. Take note. Okay, I'm going to write this particular step only for explanation purposes. So plus 2 over root of 2, all over negative 1. Is that clear?
Yes, please.
Okay, so you know this negative 1, okay, is going to affect this term and affect this term. So it will be 10 over negative 1, which will give you negative 10. This over negative 1, which will give you negative 2. This. So straight away, I can write this as, okay, in actual fact, it will be minus in bracket, just as if you have, okay, a over minus what? 1. This will give you minus a, but because it's a monomial term, to keep it. But if I have a plus b over minus 1, this will give me minus in bracket a plus b. So in effect, it will give me minus a minus b. All correct. If this was minus, then it would give you minus a and plus b. Is that clear?
Yes, please.
Okay, so I am going to write this step only for explanation purposes. So it will be minus my numerator. So 10 plus 2 root of what? Root of 2. And you can move from here to this particular step that I'm going to write. Straight away, you won't lose any math. So it will be, I know it will be divided by negative 1. So all my terms here, the positive will be negative and the negative will be positive. I have all of them to be positive. So it will be minus 10, okay, minus what? 2 root of what? 2. However, if maybe this was negative, I wouldn't have started with the minus 10 because I know that this would be negative, this would be positive. So I'll start with the positive 2 roots of 2, then I'll write minus 10 because you know the advice that you've been given. All correct?
Yes.
Okay, great. So I think that will be it for, okay, this set of questions. So with this one too, elective math students, this is format. Don't go and flex your muscles by, okay, rationalizing each of them. Okay, after you've been taught rationalizing, okay, the denominator which contains a binomial set. Okay, or those of you who know, please, that is strictly elective math. So though that could be a possible approach, but because this is format, we rule that approach out. Take note. Always go for the LCM in this nature. So usually, if we give you a binomial denominator in format, we have to make sure that it will result in what you expanding to get difference of squares straight away. Okay, so quickly, let's move on to, okay, the last set of questions. Okay, so you know, we did, okay, questions of this nature where we were, especially this one. So with this one, I will only, okay, explain, okay, you know, where you are giving values to substitutes. Okay, that's where we ended yesterday. I think we did one example or so. There were 3 questions, but we did only one as a guide to do the others. So don't worry, we will do more because, okay, we've encountered a situation of that form. So let's see. Okay, obviously we'll do A and B. Okay, then, okay, that will be it. Okay, so I've taken care of Jojo, so don't worry. All right, so thanks for the, all right, so please make sure always your mic is on mute if you are not given the opportunity to talk. So 3, okay, so in this case, as you read the question, simplify the following. Okay, hence evaluate your result correct to 2 decimal places. So this must be underlined. Even the question is bold. So if you ignore to leave your answer to 2 decimal places, it means you are just careless because it's bold. Okay, given that this is equal. So I'm going to extract all that I'm giving. Even this one, like I told you yesterday, you can underline, and make use of it when you need it. Okay, salient information, you can choose not to extract. So what am I asked to simplify? So A, this question is 2 in 1. First of all, I need to simplify this. Then after that, evaluate my results if these are, okay, the root of, the values of root 2 and root 3 given. So 2 in 1. Yeah, and I've told you, anytime you read question and you see hence to underline hence, very important. It means your second conclusion, you must conclude with hence. Or it means make use of what your previous results as well. So quickly, let's go and look at what we have there. So what are we giving? 3 root of 2 into what? Root of 2 minus 1, then plus 2 root of 3 into 2 minus root of 3. Is that clear?
Yes.
Okay, so this one is an expression, so it will be equal to, if you like, you can extract this one and attach. So comma, what have you, or semicolon, colon. Okay, but I said you can choose not to. So let's expand. Okay, if you expand, you know, always check if you can reduce. If you cannot reduce, then you go for expansion. So if you expand, you are going to get 3, okay, then times root of 2 times root of 2 to give us root of 2 squared, which is 2. Then 3 roots of 2 times minus 1. So that will give us minus 3 root of 2. All correct.
Yes, please.
Then you come and do same here. 2 root of 3 times 2, and that will give us 4 root of 3. All correct. Then minus 2 root of 3 times root of 3 will give us 2 times 1, which is 2. Then root of 3 times root of 3, which will give us 4 root of 3 squared, and that will give you 3. So now this will be equal to, okay, you are going to get this, which is 6. Okay, you know, okay, that's, let me see whether what I have there. So this cannot be combined. So I will get minus 3 root 2, then plus 4 root 3. Then what do I do? This will come and give me minus 6. So in effect, I know the first part of the question, which I was asked to simplify, I'm going to draw its conclusion because it's a direct question. So I know if this cancels out this, I will be left with this. Okay, so I'll write therefore, okay, 3 root of 2 into root of 2 minus 1, okay, plus 2 root of 3 into root of 2 minus root of 3. Okay, this will be equal to, so I'll come down. I know it won't go there. If you go there, you continue. But if you are coming down, you start writing close to the margin. But you know, this and this will cancel. So you'll be left with these two terms. But between these two terms, this is positive, this is negative. So you know the rule, the advice. Avoid starting with a negative term in your expression, in your conclusion, if there is a positive term. So I'll rather write what 4 root of 3, then minus 3 root of 2. All correct.
Yes, please.
Okay.
Mr. Hackman,
Yes, my professor.
please, will we still be given the mark if we start with a negative term?
Okay, I don't want to, because usually, okay, I have told you your final answer, okay, for you to get your final answer mark, it should reflect or it should exactly be what we have in the scheme. So if in the scheme it comes with 4 root of 3 minus 3 root of 2, okay, it's likely you won't get it. Okay, so I didn't even want to answer that question from the beginning, because I don't want to encourage you to not to start with the positive if there is a positive term. So you know. So if maybe in your conclusion, you realize that you came to write minus 3 root of 2, okay, plus 4 root of 3, and something clicked afterwards, then it means there is another step which you have to rearrange. So you come and write equal again and you rearrange. So you can correct yourself if, okay, it is an afterthought. But that's why I encourage you to think always before you write, not after you've written. Is that clear?
Yes, please.
Okay, great. All right, so I think, okay, this is it for the first part of the question. Now, the second part of the question, okay, we are going to write hence. So we're going to draw our conclusion. So hence, okay, 3, we said we are supposed to evaluate, okay, our result here. And this is the result of this, okay, using these two values. So I'll write hence 3 root of 2, okay, into root of 2 minus 1, okay, plus 3 root of what? 3. Sorry, 2 root of 3, forgive me, into 2 minus root of 3 will be equal to 4 into root of 3, and that is given. What is 4 root? I mean, what is root of 3? 1.7, okay, 3, 2. Okay, then what? Minus 3 into root of 2, and that is what? 1.414. All correct. My professors, are you with me?
Yes, sir.
Okay,
Yes,
great.
please.
So at this point, what do we get? This will be equal to, you know, you can always multiply a whole number and a decimal with your calculator. Nobody will know. Okay, whole number and a decimal. So please, at this point, wherever you put in your calculator, you can, okay, go for it now. Okay, you can make amends. Okay, now, okay, you are friends, good friends. Okay, so let's use it, no issues. It was a decimal times a decimal, you cannot. Immediately use your calculator, we will know. So let's go.
76.928.
928. Okay, then minus 3 times this. We shouldn't waste time on this. Oh, you shouldn't waste time. Hey, let me check. Am I recording?
242.
It's what?
4.242.
Okay, so 4 points. Oops. Okay, so 4 points. Okay, 242. Okay, so now, let's go. Okay, subtract. Again, using your calculator, nobody will know. This okay. So this will subtract, will give you 6. Okay, you know what you are supposed to do. So let's go.
2.716.
2.716. Okay, obviously we can't end here. If you end here, then it means you are not particular. You don't pay attention to detail. Okay, you know, protect our mouth. That's why you underline this. So let me check. Is my answer here in 2D? No. Okay. And an APR, Prof.
Please, it's not 2.716.
So it's what?
2.686.
686. Okay, so
Yes.
who gave me that value? Okay, I will have trust issues with you.
Sorry, it was a mistake.
Yeah, you see, you are now telling me that's a mistake. I have trust issues with you. Okay, so please come again with the value. 2 points.
686.
Okay, 686. Okay, so this obviously is not in 2DP. So we are taking it to 2DP. So that will give us 2 points. The first decimal place, the second. The next digit is 4. So we add 1. So 69. And don't end there. Anytime you approximate, remember I told you, don't forget to indicate your approximation in brackets. So you write 2DP. Don't write decimal places in 4. It's universally accepted as okay, decimal places. Okay, so anytime you approximate, indicate your approximation in bracket. This is equal to this, okay, in 2DP. Take note. Okay, so the last question, okay, which will be the P. Okay, the C, obviously, once you see it in green, you've been given the green light, you know where possibly you will find it. Okay, so take note. All right, so now with this one too, you've been given this, okay, and you are asked to correct 5 significant figures. This one is even bold, so you can choose what to underline. You should see. Okay, so what am I supposed to evaluate? It is this that I'm supposed to find its value without using calculator. So this is a very important information. Okay, so I will go for giving 5 minus 5 over what with 7. Okay, and here you can see that this is the first time that, okay, we have seen a set in the denominator whose value has been given. And please take note, never substitute, okay, remember I told you the other one, never substitute when you know that when you expand, okay, you multiply 2 decimals. But with this one, the advice is if you have a set containing a fraction, never substitute its value if the set is still in the denominator. You only substitute when the set appears in the numerator. Point well made.
Yes.
So it means here you cannot do direct substitution because your set here is in the denominator. So how do I make the set my numerator? By what? Okay, rationalizing. So I can take the LCM and later rationalize, or I'll rationalize, okay, that term. So I will do that. We have that flexibility. So let's go and look at root of 7 times root of 7 over root of 7. Okay, at a point I will leave you. So it will be 5 minus what? This will give you 5 root 7. Okay, then over, okay, your 7, because root of 7 squared, which is 7. Is that clear?
Yes, please.
Okay, so at this point, please take note. Because the set is appearing in the numerator, you can go and, okay, substitute your, okay, value. So the value of root of 7 was given as what? As 1 point. So into 1 point, what do you call it? 6. Okay, 4, 5, 7, 5, all over 7. Or someone can take the LCM, write it as a single fraction, then later go and substitute. Please, you should know that the 7 here is affecting only this, not the whole of that. So at this point, you use your calculator, you divide. Okay, come and subtract your result from this. But don't forget that you are looking at 5 significant figures. So your answer that you get, you take it to significant figures 5. Is that clear?
Yes, please.
So here, the major information, okay, the additional information is that don't substitute while the set is in the denominator. That's all. But once you bring it up, substitution is always allowed. And after you substitute, you always be multiplying a whole number and a decimal. I've told you you can use your calculator. Okay. And you get a decimal over a whole number, you can use your calculator. Anything concerning whole number and a decimal, obviously, calculator can be used. But not when it is divided instead the denominator. Afa.
Yes, please.
Okay, so okay, this will be it for set. Okay, thank you very much. And okay, I'm going to give you 5 minutes water break. When we come back, we'll go and see if you can do a bit of what? Binary operations. Okay, so at this point, if you don't have any further questions, we are bringing the curtains finally down on call
Please,
math said. Yes, I'm here.
please, Debbie, why didn't you like do for the 5 minus 5 over root of 7? Why didn't you like do LCM, like handle it
I
like
said it. I said it. You can do that. Remember, we've dealt with questions of this nature. We had two ways of dealing with it. Take the LCM, later rationalize, or rationalize and take the LCM. So I even said it before, so it may be you were not listening. I said it before I wrote this.
okay, but please can you conclude the for the last step?
This one,
Yes, please.
okay, I said, now you come and multiply this and this using your calculator to give you a value. You write it, then over 7. You use your calculator to do that. So if you come and get 5 minus, okay, your calculator, first of all, don't use the whole of this. Don't use your calculator to do the whole of this. Use your calculator to multiply this and this. So it means I'm going to get this equal to, okay, 5 minus a certain quantity over 7. Is that clear? After multiplying this.
Yes, please.
Okay, because immediately you write the value of this data with the, you give us a clue that you use your calculator.
Okay.
So take out the hints of the usage of a calculator. That's my point. So at the point where you write the value of this up here, then you can still use your calculator. Okay, come and do 5 minus the value that your calculator will give you after dividing the number that is here by 7. Then now you come and have 5 minus that. Also, you use your calculator. But when you don't end there with that value, come and subject the value through what you were asked to leave your answer in. So you were asked to correct your answer to 5 significant figures. So your final answer must be in 5 significant figures. Otherwise, you get
Yes.
your final answer wrong.
Okay, thank you.
You are welcome, my professor. Okay, so once again, that will be it. Okay, if you don't have any further questions, that will be it for call mark 6. Okay, thank you very much. God bless us all.
Mr.